Okay, we're working on problem number, what number are we on now? We're on number 24. And 24 is going to be 1 plus x to the r. And r is going to be any real number now. All right, now when it's centered at 0. If you write this down, I'm going to write f of x down. And this is a nice form to know, by the way. It's going to be useful later on. What do you do? Write derivatives down, f prime. You can get r, and then you get 1 plus x, and then you're going to reduce r by 1. Put the next derivative down. That's going to be r times r minus 1 times 1 plus x to the r minus 2. I think you get a feel for it. It's going to write a few more, not a few more down, a couple more down. That's going to be r minus 1, r minus 2 times 1 plus x, r minus 3. Let's write the fourth derivative down. I'll stop there. That's going to be r minus 1, r minus 2, r minus 3 times 1 plus x to the r minus 4. Let's evaluate this at the center. And the center 0 then. So f of 0. Again, that's right up here. That's going to be, 1 to the r. So that's going to be 1. Let's do f prime at 0. What's that going to be? That's just going to be r. F double prime at 0. That's going to be r times r minus 1. F triple prime of 0 is going to be r minus 1, r minus 2. And let's do the fourth one. The fourth derivative evaluated at 0 is going to be r minus 1, r minus 2, r minus 3. It's got a really nice pattern to it. So let's write this down. So it's going to be 1 plus x to the r is going to be equal to, we're going to do the expansion now. It's going to be, and we'll write the sum down as well, by the way. It's going to be 1, and that's going to be, let's see, we're starting at 0, so it's going to be, let's make sure I'm saying this right. Yeah, 1 plus x to the r. So 1, and then x to the 0. I'll put 0 factorial over here, by the way, plus, the next one's going to be r, x to the first power, and then you can get 1 factorial over here, plus r minus 1, and that's going to be x to the second power over 2 factorial. It's got a very nice pattern to it, plus r minus 1, r minus 2, x cubed over 3 factorial, yada, yada, yada. All right, it goes on forever. And I can write this as a sum now. And the sum's going to be, let's take a look at this. And I have to write down a sum now, right? So the sum, kind of looking at it, and I'm going to start at 0, n equals 0, go up to infinity. And what do I see over here? I definitely see x to the power. I see that much. So x to the n. And I point out what I mean by that. I'm seeing that every single time. X to the 0, x to the 1, x to the 2, x to the 3. And then I'm looking at these coefficients over here. And they sure do remind me of binomial coefficients. All right, let me write that binomial coefficient down that you learned about in your pre-calculus courses. And that was for some integer n, by the way. But now we got this letter r now, which seems rather peculiar. And that's going to be n over here. All right? Now, by the way, same pattern. It doesn't matter what the r is. All right? I kind of want to write a few down for it. And this is a general form, by the way. And before I general form, I'm gonna do the. I guess we should do the ratio test on it. All right, let's write this down. So limit n goes to infinity. The absolute value. Let's see, it's going to be r n plus 1 times x to the n plus 1 r n over x to the nth power. Right, I got to do the limit. And the complicated thing about the limit is those binomial coefficients. So let me write them down for you. So r n plus 1, looking at this thing, r factorial, and then it's going to be n plus 1 factorial, and then you're going to take the top r minus the bottom, so it's going to be r minus n minus 1 factorial. All right, let's do Rn. It's going to be r factorial, and then it's going to be n factorial. I could put in that parenthesis, so just erase that, put n factorial down. N factorial, and then it's going to be r minus n factorial. All right, so let me try to simplify that. I'm really kind of dividing it. So I'm really taking, r n plus 1 and dividing it by this over here. Let me write that down for you. Hope it's going to be pretty easy to do. That's r factorial, n plus 1 factorial, r minus n minus 1 factorial, and now I'm dividing by that rn, or multiplying by its reciprocal. Let's write that down. N factorial, r minus n factorial, over r factorial. Well, what's nice about this, we got some cancellations going on over here. I want to further cancel. I'm seeing the n, and that's going to be n plus 1 now. And this r minus n factorial, and the bottom is r minus n minus 1. So I'm left off with r minus n on top. All right. So let me just see if I did that right. Kind of looking around again. The n factorial, I got that pretty good. And the r minus n, and then will be r minus n minus 1. Yeah, that looks pretty good. And I'll write that down now. So it's going to be limit n goes to infinity, absolute value r minus n over n plus 1 times, well, I got this ratio over here, and it's just going to be x now. Now what happens in a limit? The limit depends on n. If I look at that, it's a fairly easy limit to do. It's just going to be, the absolute value of x. And when about this, the absolute value of x has to be less than 1. That means x is between minus 1 and 1. All right? So if you want to test the endpoints, I guess you could do that too. Let me just go over here and kind of erase things over here. And let's test the endpoints out. So I got some problems over here, and some of the problems over here, just looking at it, if I tried the 1, I'm sorry, I made a mistake over here. I gotta erase it now. I might have said something and wrote something differently, but x is between minus 1 and 1. So if you try 1 out, what do you get? You get the sum of these binomial coefficients. Oops, Rn. Well, that's going to diverge, right? And if I did the other one, that's also going to diverge, by the way. It's going to be Rn. It's alternating, by the way. At least with the x's. That Rn's still a little mystery to me. Divergent over there, all right? I'm going to say these Rn's are going to numbers, all right? And they're not going towards 0, all right, at this point. So I'm going to say the interval of convergence over here is going to be from minus 1. So the r, the radius, is going to be 1, and the interval is going to be minus 1 to 1, all right? What I'm going to suggest you do is look at the key now and see what's written in the key, by the way. And this could be in a really important series. It has a name, generalized binomial. And you want it of that form, by the way. Someone says, what form do you want? You want the 1 plus x to the r. I just want to go through some, computations. Like if I have, 1 plus x to the 1/2, what's this going to equal? Well, just kind of looking at it, I can write it down. And what am I going to get over here? It might look strange to you, but I'm going to get, first term's going to be 1. That comes from this over here. What's the next term going to be? It's going to be plus, let's take a look at it. It's going to be r, which is 1/2, over 1x. That's not so bad. Now the next one, again, we're doing this over here now on the third term. That's going to be 1/2. It's going to be a little strange over here. It's going to be 1/2, and then it's going to be 1/2 minus 1 which is minus 1/2. And then you get x squared, and you get over 2 factorial, which is 2. All right, what do you get there? Let me write that down for you. So it's 1 plus 1/2 of an x. This is going to be what? Minus 1/8, right? Of an x squared. I think you get the idea that these things over here, they're computable numbers, by the way, and you want to be able to compute those, and you can take them out a few times. Thank you.